Welcome to The Explainer. I am so glad you're joining us today because, wow, we are going on an absolutely mesmerizing, hyper-speed journey. We're going to track the entire life of a Coca-Cola can. We'll start with a massive raw metal coil and go all the way to that ice-cold, refreshing drink sitting right there in your fridge. So, let's just dive right in.
Millions. To really get a grasp on this process, you kind of have to wrap your head around the unimaginable scale of this operation. We're not talking about a couple thousand cans a day here. No, picture thousands of bright red Coca-Cola cans racing across high-speed conveyor belts every single second. Imagine endless rows of them disappearing into massive warehouses, those tiny water droplets forming on the chilled aluminum, all while robotic machinery moves perfectly in sync. Millions of times, every single day, this industrial choreography is executed flawlessly. It's honestly mind-blowing.
Here's our quick roadmap for today. Step 1, forming the can body. Step 2, washing, coating, and printing. Step 3, necking, filling, and sealing. And Step 4, quality control and distribution.
All right, Step 1, forming the can body. Everything starts with the raw material arriving at the factory. Imagine these massive aluminum coils, literally weighing several tons each, rolling up on trucks. Giant overhead cranes carefully hook them, hoisting them up and dropping them onto automated unspooling machines. The unspooling begins, and this giant sheet of highly reflective aluminum just feeds seamlessly right into the high-speed machinery. Now, this mechanical transformation, it is deeply satisfying, and it happens so incredibly fast you almost can't process it. First, powerful stamping presses are just rapid-fire punching out thousands of circular aluminum discs every single minute. Next, each flat disc drops into a deep drawing press where it's forcefully stamped into a shallow little cup. From there, body-making machines take over, violently stretching that cup into the tall beverage can we all recognize, giving it those incredibly thin walls. And to make sure they're flawless, the top edge gets trimmed perfectly for a totally smooth, uniform height. The result is thousands of identical, shiny cans just marching along in these perfect rows.
But wait, here we run into a pretty critical engineering challenge. If you pour highly acidic, carbonated soda directly into raw aluminum, well, the liquid and the metal are going to react. It would completely ruin both the drink and the can. So how on earth do we prevent the soda from reacting with the metal?
Well, the answer to that is in our next phase. Step 2, washing, coating, and printing.
So here is exactly how we protect both the can and the beverage inside it. First up is industrial washing. The newly formed cans zoom through these huge washing machines, where high-pressure water jets completely strip away any lubricants or microscopic dust left over from the manufacturing process. Next is the secret sauce, the interior protective coating. A completely food-safe layer is sprayed directly inside every single can. And finally, they travel on a continuous conveyor straight into these super long curing ovens. The coating is quite literally baked right into the metal, with steam just billowing off the lines as it sets.
Once the inside is safe, the blank exterior of the can goes into these ultra-fast decorating machines. Using multiple rotating printing stations, that iconic, unmistakable red Coca-Cola graphic is printed on with unbelievable precision. But they don't stop there. A protective clear varnish goes right over the ink, and the cans hit yet another set of curing ovens. When they pop out the other side, they've got that famous, super glossy Coca-Cola finish.
Okay, now that we have a beautifully printed, perfectly protected can, we move into Step 3, necking, filling, and sealing. This is where the engineering gets insanely precise because we're finally ready for the actual beverage.
Before filling, though, the cans go through a process called necking. It's a fun bit of industry jargon, but what it means is the top of the can passes through a series of precision rollers that make the opening narrower. Why do this? It's brilliant optimization. By narrowing the top, the factory drastically reduces the amount of metal needed for the lid, all without losing any structural strength. Then, the rim is shaped perfectly to get it ready for lid attachment. All right, time for the main event. Thousands of empty cans get one last rinse before entering this highly enclosed filling line. It is an absolute marvel of speed. Ice-cold, carbonated Coca-Cola flows in with remarkable velocity, and the machine perfectly controls the exact volume dropping into every single can. Honestly, you can practically see the tiny bubbles rising. Instantly, an aluminum lid is dropped on top, and high-speed seamers lock it all down with double-seam sealing rollers. It yields a perfectly sealed can every single time, with hundreds of them moving in total synchronization.
Which brings us to Step 4, quality control and distribution. Because, let's be real, All that speed means absolutely nothing if the cans aren't perfect.
To guarantee that perfection, they use automated inspection systems that move at blinding speeds. As the cans fly by, laser scanners and vision cameras verify the fill level, the seam quality, the pressure, the weight, and the label accuracy. Boom, boom, boom. They are relentlessly scanning thousands of cans a minute.
And the coolest part? What happens when a sensor spots a tiny flaw? The factory has this ruthlessly efficient reject system. If a can has the wrong pressure or a slightly bad seam, high-speed air jets literally blast the defective can right off the line. It happens in the blink of an eye. Only absolute perfection makes it through.
Those perfect cans are then ready for final packaging. And the sheer scale here is wild. They're grouped into 6-packs, 12-packs, and 24-packs. Robotic machines wrap them in recyclable cardboard or shrink film. Then, automatic palletizers swing into action, stacking cartons into these massive towers before wrapping them securely for transport. Finally, forklifts haul them into vast, seemingly endless warehouse aisles, ready for the delivery trucks to take them to stores all over the world.
To sum up this jaw-dropping journey, from aluminum coil to refreshing Coca-Cola, precision, speed, and quality in every can, that really hits the nail on the head. In just a matter of minutes, a massive, flat metal coil was stamped, stretched, washed, baked, painted, necked, filled, sealed, laser scanned, and packaged.
I want to leave you with a thought for the next time you reach into the fridge. When you crack open that ice-cold can, are you just going to hear the fizz? Or will you hear the incredible engineering behind it? There is an immense industrial choreography hiding inside your everyday beverage, a real testament to human ingenuity and scale. I hope this explainer gave you a whole new appreciation for that little aluminum cylinder. Keep asking questions, and I'll catch you on the next one.